Hello student friends, I again welcome you to my next lecture on psychrometric processes, and today we'll solve some basic numericals on psychrometric processes that we learned in the previous video. So first numerical is air at 1 atmosphere and 15 degrees Celsius and 60% relative humidity is first heated to 20 degrees Celsius in heating section and then humidified by introducing water vapor or steam. The air leaves the humidifying section at 25 degrees Celsius and 65% relative humidity. Determine the amount of steam added to the air, and second, the amount of heat transferred to the air in the heating section. So basically air at 15 degree and 60% RH is given. So we'll first plot this 15 degrees Celsius and 60% RH air on psychrometric chart. Then we have to heat it to 20 degrees Celsius and then humidify it to 25 degree and 65% RH. So let us plot this on psychrometric chart. So firstly 15 degrees Celsius and 60% RH. So 15 degrees Celsius dPt. So 15 degrees Celsius dry bulb temperature and relative humidity is 60%. So 15 degree and 60%. So this is, I'll mark this as 0.1 and is heated to 20 degrees Celsius in heating section. So it is only heated to 20. So this is the case of sensible heating. So as we learned in the previous lecture that sensible heating is results into increase in dry bulb temperature, but its specific humidity omega remains constant. So I moved 0.1 to 20 degrees Celsius dPt, which is 0.2 here, 0.2. This air is then humidified by introducing water vapor, so or steam, and this results into humidification of air. So its temperature and humidity increases. So final condition of air is 25 degree Celsius dBT and 65. So 25 dry bulb temperature and 65%. So 65 RH is between 60% relative humidity, 70%. So it lies somewhere in between this and 25. So I will mark this as a 0.3. If I join this point, it represents the process. So let me join 2 to 3. So this is 2 to 3. Now the question is to determine the amount of steam added to the air. So amount of steam added to the air means we know that the air is humidified with the help of steam from process 2 to 3. So amount of steam added is nothing but amount of moisture added from process 2 to 3. So 2 to 3 is clearly the process of heating and humidification with the help of steam. Actually it is humidification, but because of addition of steam some temperature may also result. That's why you can observe dBT increases from 20 to 25. So omega corresponding to 0.2 is approximately 0. Suppose some temperature 0.007 and point corresponding to 3 is lies here. So which is which comes to be 0. Suppose 0.13. So 0.007 is the omega 2 and omega 3 is 0.0013. So by subtracting this omega 3 minus omega 2 gives you the amount of moisture added during the humidification process. So amount of steam added or moisture added is omega 3 minus omega 2, means 0.0013 minus 0.007, which comes to be 0.006 grams of water per kg of dry air. So answer is 0.006 grams per gram of air. Second is amount of heat transferred to the air in heating. So while heating the air from section 1 to 2, amount of moisture they have asked is amount of heat added during this in the heating section. So we know that heat is calculated with the help of enthalpy. So this is H1 and this is H2. You plot the parallel line H2. So H1 is approximately, this blue lines indicates, black line indicates the enthalpy. So 2040. So 20 to, it comes to be 30. So I think 32 is the H1 and H2 it comes to be 38. So 38 minus 32 means approximately 6 joule per gram of dry air, or you may say that 6 kilojoule per kg of dry air is the heat added in the given air. So this is the numerical one. Now next numerical is air enters an evaporative cooler at 1 atmosphere and 36 degrees Celsius and 20% RH at a rate of 4 meter cube per minute, and it leaves with a relative humidity of 90%. So as you can observe that this is the example of humidifier, or you may say evaporative cooler or desert cooler, where you can add some hot dry air, and because of the water spraying or humidification, its humidity increases from 20 to 90%. So in the given evaporative cooler, the initial air temperature and relative humidity is given, and the exit relative humidity of 90% is also given. So what you have to determine is exit temperature of air and required rate of water supply to evaporate. So let us first plot this on psychrometric chart. First plot is on psychrometric chart. The given condition is 36 degrees Celsius and 20% RH. 36 degrees Celsius, so 35 dpt and 20% RH. 36 and so 20% RH. So you can plot your point here, point 1, and this air is then humidified in the humidifier up to 90% RH. So we all know that the evaporative cooling is, you may also approximate it as a adiabatic cooling. So in this process, this is the constant enthalpy process. So we have to move the air from point 1 on constant enthalpy line, which goes up to, sorry, let me use the line from this state 1 to 90% RH. So I plot this point 2 on, which is the final condition on 90% RH line, and this is the constant enthalpy line, which is the evaporative cooling process as we studied in the previous lecture. So what you have to determine? Exit temperature of the air. So first exit temperature of air comes to be 20 degrees Celsius. So first answer is exit temperature of air after humidification is 20 degrees Celsius. So 36 degree 20% RH is air enters, and in the desert cooler exit is 20 degrees Celsius and 90% relative humidity. The second is required rate of water supply. So required rate of water supply to the evaporator cooler. Let us see required rate of water supply. So required rate of water supply is nothing but whatever amount of water is sprayed in the evaporator that goes to increasing the humidity. So you can plot the relative this specific humidity line, and where you can find the omega, respective omega. So this omega 2 is 0.014, suppose 0.014, and omega 1 is 0.07. 0.007. So subtracting omega 1, omega 2 minus omega 1 is the gram of water per gram of air, or kg of water per kg of air, which comes to be 0.07 kg of water per kg of dry air. But the amount of air is given. So for the given air, how much water supply is required? So you can multiply this omega with the mass of air. So the formula is mass of air into delta omega. So mass of air is given as 4 meter cube per minute. So again it is in meter cube per minute, and this omega, delta omega, is in kg of water per kg of air. So for that you have to find out specific specific volume, because this mass of air is given in meter cube per kg of air, meter cube per minute. So for that we can find out the specific volume. The specific green lines indicates the inclined green line indicates the specific volume. So as you can observe, the specific volume at point 1 means initial state of air is in between 0.85 to 0.90. So you may take it as approximately 0.88. So specific volume is 0.88, and we know that density is nothing but 1 upon specific volume, or vice versa. So you can write as you can multiply it with the specific humidity or divide by 0.88. So it comes to be 4 upon 0.88 into change in the specific humidity, which is 0.07. Then you will get your answer. So please comment your answer in the comment box and stay tuned. Thank you and happy learning.